Next topic, derive an expression for equilibrium speed of Porto governor. So first by resolution of forces method. So for simplification, we'll just take half of the Porto governor with the ball and two links attached to the spindle. The lower link is away from the central spindle. Fc is the central force acting outwards. Small w is the weight of the. You will see this. Let the force acting given as shown in the figure. Let small m be the mass of the ball in kg. Small w weight of each ball, that equals to small m into g newtons. Capital W weight of the central load, capital M into g, that is in newtons. R is the radius of rotation in meters or mm. Small h is the height of the governor. H, as you can see from the figure, is half the height of the governor spindle. Is the height of the governor, that is m or meters or mm. Small capital N is equilibrium speed, that is in rpm. Capital M is the mass of the sleeve in kgs. Fc centrifugal force in newtons. T1 is the tension in the upper arm in newtons. T2 tension in lower arms in newtons. Alpha inclination of the upper arm. Beta inclination of the lower arm. Omega angular speed of the governor, that is radians per second. Now the forces at point E, as you can see the point E are, first one is half the central load W by 2 because of the half is taken by the half of the other ball. Second, tension T2. Now resolving vertically of these two forces, we have W by 2 acting downwards and T2 cos beta is the upward force, as you see from the diagram. From trigonometric triangle, this T2 cos beta is upwards. Therefore, T2 equals to W upon 2 cos beta, equation number 1. Now the ball is under the action of following four forces. So tension T1, the tension T2, centrifugal force Fc, and weight of the ball small w. Now resolving these forces vertically, so we have T1 cos alpha plus T2 cos beta plus W. So T2 cos beta is nothing but W by 2. Capital W by 2 plus small w. Resolving forces horizontally, we have T1 sin alpha plus T2 sin beta equals to Fc. T1 sin alpha plus W upon 2 cos beta, T2 is W upon 2 cos beta, sin beta equals to Fc. Now T1 sin alpha plus W by 2 cos by sin beta becomes tan beta equals to Fc. Now T1 is nothing but from equation From equation 2 we can see that T1 is W plus W by 2 cos beta alpha into sin alpha plus w by 2 tan beta equals to fc. Now w by 2 becomes tan sin alpha cos alpha becomes tan alpha plus w by 2 tan beta equals to fc. Dividing both by tan alpha, we get w plus w by 2 plus w by 2 tan beta by tan alpha equals to fc by tan a. W plus w by 2 1 plus k equals to fc by tan alpha, where k is tan beta by tan alpha. fc is w plus w by 2 1 plus k equals to m into omega square r upon tan alpha is r by h. So r by get cancels, the omega square m omega square into h. Omega square is w plus w by 2 1 plus k upon m into 1 by h. H is w by 2 1 by k plus m into 1 by omega square, or h is w by 2 1 plus k by m into 1 by n square 60 by 2 by the whole square. N square equals to w by 2 1 plus k by m by 1 by h 60 by 2 by the whole square. If friction is considered, n square becomes w plus w by w plus bracket w plus plus or minus f by 2 1 by k 1 plus k by m into 1 by h 60 by 2 by the whole square. F is positive when sleeve moves upwards. F is negative when sleeve moves downwards. So this is by the resolution of forces. Now by instantaneous center method. So instantaneous center method, same figure, extend it till taking the moments about instantaneous center. Fc equals into AF equals to W into IF plus W by 2 into IE. W into IF, W by 2 IF plus IFV. Dividing AF on both sides, FC equals to W IF by AF, W by 2 IF by AF plus FE by F. W into tan alpha equals to F, W by 2 tan alpha plus tan beta. Dividing both sides by tan alpha, FC upon tan alpha equals to W plus W by 2 1 plus tan beta by tan alpha. W plus W by 2 1 plus K. Tan beta by tan alpha is K. M omega square R by H equals to W plus W by 2 1 by K. R get cancels, we have the M omega square H equals to W by 2 1 plus K. Of omega square equals to W plus W by 2 1 plus K upon M into 1 by H. 2 pi omega 6 to the whole square equals to W by 2 1 plus K by M into 1 by H. N square equals to W by 2 1 plus K M into 1 by H 60 by 2 by the whole square. N square equals to the M plus M by 2 1 by K by M and G into H 60 by 2 by the whole square. This was about the derivation put together by instantaneous center method. Now some formulas. Given effort Q is 2W1 by K plus KW into C. Q is C into M plus M into G if K is not equals to 1. Given power equals to 4C square 1 by 1 plus 2C H W plus W. Or given power is effort into lift. Given power is 4C square 1 by 2ch W plus W by 1 plus K if K is not equals to 1. So change of power, change speed, N2 plus N1 into 100. Coefficient of sensitiveness if K is not equals to 1 is F upon W plus W. Coefficient of sensitiveness K equals to 1 is W. K is not equals to 1 is W upon 2W 1 plus K by W. Equilibrium speed N equals to W plus W by M 1 by 60 by 2 by the whole square. When K equals to 1, N1 square equals to W plus W by M 1 by H1 60 by 2 by the whole square. Or M by M G by H1 60 by 2 by the whole square. K is not equals to 1, K is tan alpha by tan beta W by 2 1 plus K by M 1 by H 60 by 2 by the whole square. Maximum speed when k equals to 1, w is w by m 1 by s2 is equal to the whole square. When k is not equals to 1 and 2 square, w plus w by 1 plus k m 1 by s2 60 by 2 by the whole square. Range of speed n2 minus n2 minus n1. Centrifugal force Fc equals to em omega square r, or em 2 pi and 60 by the whole square into r. With friction on sleeve F, n1 equals w plus w plus or minus f m upon m into 1 by h1 60 by 2 by the whole square. Maximum equilibrium speed w plus w plus or minus f m 1 by h2 60 by 2 by the whole square. Sensitiveness n2 minus n1 by n2 plus n1 by 2. Total lift or travel of sleeve 2 into h1 minus h2, 2 into h2, 2 into h1 minus h2. Fall 2 into h1 minus h, lift 2 into h minus h2. H is the mean height.